Continuing with section 11.6, we are talking about the ratio test. Here is the third example. So always remember, when factorials are present, ratio test is the key. So we start by finding out what is an. In this case, an is 2n factorial divided by n factorial whole squared. So that an plus 1 will be, now notice the 1 is being added in n, not 2n. So it will not be 2n plus 1, but it will be 2n plus 2, because we get 2 times n plus 1 factorial, which will mean it will be on the top is 2n plus 2 factorial, and at the bottom n plus 1 factorial whole squared. So here we take the ratio, absolute values. So what do we get? First, the top term, 2n plus 2 factorial, and over here n plus 1 factorial. I am going to write it because it's a square, so I'm writing it twice. N plus 1 factorial into n plus 1 factorial times, or we have to reverse the take the reciprocal of the an. So it will be n factorial whole square. So it will be n factorial times n factorial divided by 2n whole factorial. Okay, now the top here, this one is bigger than 2n. So I expand. So I get 2n plus 2 then 2n plus 1, and then I can say 2n factorial. Over the bottom here, so we have an n factorial here, you see that, and we can easily get an n factorial from the ones over bottom here. We can write them as n plus 1 times n plus 1 times n factorial, and then this repeat the same, n plus 1 times n factorial, and at the top here n factorial times n factorial divided by 2n whole factorial. So now notice here, this n factorial cancel these, this 2n factorial gets cancelled with by that, and then we are left with 2n plus 2 times 2n plus 1 all divided by n plus 1 and n plus 1. What do I do now? Well, simplify. We can write it like divide the top each term by n. So when I divide this term by n, I get 2 plus 2 over n. Then I divide the next term, this by n, I get 2 plus 1 over n. And then when I divide this one by n, I get 1 plus 1 over n. And last one, when I divide this by n, I get 1 plus 1 over n. And this goes to the 2 into 2 over 1 into 1 equal to 4 as n goes to infinity. So 4 is bigger than 1. So ratio test series diverges. So this is how you apply the ratio test.